Hey, what's up everyone, and welcome back to another video. In this video, we're gonna see how we can combine Matplotlib, Plotly, Seaborn, and all of your other favorite Python visualization libraries into a Shiny for Python app. One of the things that I love about Shiny is that, you have this capability. I feel like so many times in the past, I've done some analysis in Python and then been working for a client, working for a company that requires me to port that into something very specific, not using Python. Whereas if I had Shiny for Python, 5 years ago, I could have easily just spun up a dashboard using all of the same visualizations. As a reminder, in the last video in this series, we built a dashboard that looked like this with some placeholders where we can put different Python visualizations. In this video, we're going to fill in those placeholders with like a heat map, another type of heat map of the actual US, and then change this top graph to use Altair instead of Plotly. And throughout this process, we'll learn about all the different kind of annotations and how you can incorporate many more libraries than just what we cover in this video. And then finally, we're ultimately working towards a dashboard that looks like this by the end of the series. I think the only thing we might not cover in this video is really the styling and the coloring and some of these final tweaks. So we might not have all of these colors set by the end of this video, but we'll have all the graphs and we'll leave all of the styling details for video 5. Should be a lot of fun. So to get started with the code, I recommend going to this GitHub URL. I'll link it in the description. And depending on what part you want to jump in on, you can scroll down and see the different parts of the series. We're going to be building off of the source code for part 3 in this video. So you can go ahead and look at the code right here. Or if you want to specifically have all of this code locally, what you could do is you could fork the repo so that you have your own personal copy of it. Once it's forked in your personal copy, you're going to click code. You're going to copy this URL, open up the terminal window, and you're going to want to do git clone and paste in that link. You're going to navigate into that folder, and then you want to get all the branches in that repo. So you're going to do a git fetch origin, and then finally you can do git checkout video 3. And it will switch to the branch that has all of the code from video number 3. You want to navigate into the sales folder. You might need to install, if we look in that folder, there's requirements.txt. You might need to install the requirements.txt by doing pip3 install -r requirements.txt. And then the final step that you might want to do, if you use VS Code, you might have access to this code period to just directly open that from your terminal. And we see we have our app.py right here, and I can click run, and the dashboard loads right there, and we can start working on this code. You might even create another branch that's separate from this code, however you want to approach it, but that's my general recommendation. First, we'll quickly want to change this to video 4 of 5. But after that, I would say a good starting point would be to really understand how to render Matplotlib visualizations using Shiny. And the kind of keyword for that is this render.plot function. So how about we start down here with the heat map? And we'll start by just doing a simple Matplotlib plot, but then we'll make a heat map using Seaborn. And ultimately, there's a lot of Python graphic libraries that are all based off of Matplotlib. So even though this render.plot really focuses on Matplotlib, it covers so many different libraries in Python because so many are based off of Matplotlib. So we can go down here to this heat map, and we could start plotting a chart down there using Matplotlib. So to do that, we'd want to add a render.plot annotation here. We want to pass in a function, so I'll call this plot sales by time, how about? And then in that, we'll pass in our Matplotlib code. So as a reminder, if you're using Matplotlib, you can import it by doing import matplotlib.pyplot as plt. That's typically how you'll see it. Down here, we could immediately plot something with Matplotlib by doing like plot dot, how about bar chart? We could pass in some random numbers for our x, pass in some random numbers for our y, and that will actually work right there. As you can see, we have a little chart, but let's make this actually use our data. So as a reminder, we're using sales data. We have a bunch of different products, how many times they were ordered, the price of the order, and when they were ordered. So this is like a Unix timestamp. But ultimately, we can convert that to a date time object and get more easy like months and hours from it. So if we want to do sales by time, and I'm thinking of time of day, so what hour from 0 to 24 were these purchases made? Well, to do that, we might want to add another column. So we're accessing our data frame using this DAT reactive calc. That's over here at the top of our code, found right here. I'm going to add another column to that. I'm just going to call this hour. And hour is going to be equal to df order date, our date time object, .dt.hour. We can easily access a numeric integer hour from that. If we go down to our data frame, scroll to the right, we see we have an hour now, 14, 20, 18, that all makes sense. I think the max actually is going to be 23. So if you wanted to like offset this by 1, you could, but I think it actually makes sense starting at 0, going to 23, because ultimately once you get to 24, it turns to the next day. So we don't actually want to see 24 here in our data. And then we can access a simple bar chart by doing something like sales by time or sales by hour, how about, equals df dot value count, or df, how about hour, and then grab the value counts of that. If we printed sales by hour and rerun this, or actually just open our terminal, we see we get something that looks like this, that has the hour and then the count. The last step to make this a little bit easier for us, I would recommend doing a reset index, and then watch what it prints out. Now it prints out a nice data frame with hour and count. So we could easily pass in a x equals sales by hour, and then a y, which would equal, or I guess they use height now these days, but I think if we pass in y, it's fine too. Sales by hour count. What does that give us? I guess it likes the height now. We see we get something that looks like this. And you could pass in like your x ticks and different Matplotlib keyword arguments. So our x ticks might be like numpy. Do we have numpy imported? I guess we don't, so I'm going to import that as well. You could do something like np.arange 0 to 24. I think that would give us the right amount of ticks. Is there no x ticks keyword argument? When in doubt, Google search, or actually, you could use Copilot, add tick marks from 0 to 23 to my Matplotlib chart. Except, so it looks like I have to do it separately. That's weird. Run this. I didn't save it, oops. Cool. So that gives us all the tick marks that we need. That's a simple Matplotlib chart. You could obviously customize this as you need. It knows to output that plot object, but you could also return a figure here and it still would work. But we actually want a heat map using Seaborn. So we can also do that within this render.plot function. If you go to Seaborn, the documentation, you'll see that it's a Python data visualization library based on Matplotlib. And there's a lot of other Matplotlib-based or Matplotlib adjacent libraries that we can use. Some immediately that I know about are like Plot9. You can use pandas directly. There's a lot of pandas.plot functionality that you can immediately tap into. So I could do something like, let's see what would make sense to do. Sales by hour dot plot. And then I could pass in the column names, hour, x equals hour, y equals count, and watch this. It didn't do exactly what I wanted it to do, but you can see that it does have plotting ability. I think I need to specify that this is a bar chart. Kind equals bar. So we see we get a bar chart now. And in this situation, it looks like it sorted it from greatest to smallest, but I would really want it to be in order of 0 to 24. So you might be able to, you can specify these things, you can change this around, but pandas also works. You can use libraries like HoloViews, XArray, GeoPandas, a lot of Matplotlib-based plotting you can do. I'm gonna delete this real quick, just wanted to show that as an example. But what would it look like to do a Seaborn heat map like we have in ultimately the final plot that we're working towards? To do that, go to the Seaborn documentation, maybe look at API, look at somewhere in here, probably have a heat map, and look at how it's done. We have a pretty simple heat map that we want to deal with. We want to just have basically a 1D array, but I think that only takes in 2D, so we kind of have to play around with it a little bit. So I'm going to also import Seaborn. And we can change our chart to do something like, probably want to keep the sales by hour. We look at our docs. Basically takes in that 2D array. So we just need to format our values to be this 2D shape. We could do that in here by switching this up a little bit. So instead of resetting index, I'm going to actually re-index it. I'm going to pass in that numpy range 0 to 24. Basically set this and sort it to be between 0 and 24, but use that as the index. So no longer is like our own separate column. We have that. We also, as like good practice with re-index, you should probably have a fill value. So if ever you don't have one of those numbers, we want to have that still show up in the heat map. So it would just be 0. In this situation, we're counting a lot of product sales, so we should always have greater than 0 value, but this is just good practice to do. What else do we need to do here? I think ultimately we might get errors if we try to do the heat map by just passing this sales by hour. I think it expects, it might take a data frame. Let's see. Pass the fill value into the wrong spot. Very close. I think we're going to have to reshape this. Reshape. We want it one column and then however many rows we need, which would be like 24. So I probably could reshape this as 24 to 1. It should work. I guess we got to do sales by hour dot values dot reshape to turn it into numpy, and then numpy accepts heat map data. Let's see what happens there. Nice. That's our sales by hour. I don't love these colors, and I would love, I'm trying to think of other things. If we look at our final visualization, we have like the numbers right inside of the heat map, and I think that looks kind of good. So I'll pass in some parameters to this to give it more of that look. So annotation equals true. And honestly, there's a few different ways you can look into the documentation to see these different options. You can also honestly use like a large language model like ChatGPT or something to help you get it exactly how you want it. So a little bit of combo of this is how I figured out how to kind of get parameters how I wanted. Didn't need any X-tick labels. 0 there is kind of unnecessary. Y-tick labels. It's kind of nice to have more of an hour look. So you could do a list comprehension here, which you could just do something like I:00 for I in range 24. And I think that's probably some good parameters. Run this. What does the updated graph look like? Oh, need some commas. Do I have commas everywhere? Oh, wow, that's looking a lot more like it. I think the only other thing we would want to add is some labels. And you can actually use the same Matplotlib labels to fix this. So plot.title might be something like number of orders by hour of day. The X label will probably be hour of day. And the Y label would just be order count. Like that. We've got a nice heat map there. Perfect. That looks good. And you see, all of this, it knows to render the plot properly. And as we see, we're editing some Matplotlib things, but we ultimately use Seaborn, and we get that chart there. So you have access to all of Seaborn, and you'll use the render.plot for that. Now, what are our other options here? So the other big category of things that we might plot with Shiny are IPython widgets. So if you go to this documentation page, I'll link it in the description, we can see that there's all sorts of ways to plot Jupyter widgets within Shiny. So some that show up right out of the box here are Altair, Bokeh, Plotly, Pydeck, etc. And what you'll see if you read into this documentation is they all kind of are under this subcategory render widget, but kind of give some fancy special things for specific libraries that Posit has specifically built support for, like Altair, Bokeh, Plotly, and Pydeck. You'll see that instead of using the render widget annotation for some of these, you can directly use an annotation that's specific to that library, like render.plotly here. So to do that, we need to import render.plotly from Shiny Widgets, and then we can kind of leverage Plotly as we expect. And we've already actually seen this in our code. So if I go back to our VS Code, we see that we have render.plotly already being accessed here. So you can kind of keep that as is. But let's say instead of using Plotly here for this first graph, so we'll see this first graph if I make it a little bit bigger, how about we switch that to use render Altair, so the Altair Python library. How would we change it to allow us to do that? Well, the first thing we would need to do is also import render Altair. That's the first step. We might also just import render widget if there's other extra cases that we want to deal with here. Okay, and now how do we convert Plotly to render Altair? Honestly, what I might try is seeing what our good old friend ChatGPT or whatever your LLM of choice recommends for this. So I might type in convert this Plotly code into Altair in Python. Okay, and I'm curious if I just copied this code and I pasted it in here, we're going to have success. Well, we're not going to have success immediately because we're not even importing Altair. So import Altair as ALT. Then it is saying sales over time, Altair, missing 2 positional. Oh, this is not necessary to pass in because we already know it. I guess we would have to grab df equals dat. Then our city is input.city. It's kind of confused by the Shiny stuff. What does this look like now? City is not defined. What are you talking about? Input.city. Come on, does this work? Look at that. We already got a nice looking Altair chart. Oh, this is render.plotly. It actually works just fine. It's just the type of thing is if in the future something changes and this needs to be very custom for Plotly, you might run into errors here, so you'd want to actually use the annotation render Altair. So if there's a specific annotation for the library that you're using, go ahead and use it. But if you don't see one for your IPython widget, just use render widget, and that will kind of work for most situations that you need. We can see that if we change this, it does update. We kind of get good results overall. That's pretty cool to see. So other than Altair, Plotly, Bokeh, Pydeck, what other options do you have with IPython widgets? Well, this is a list of different visualization Jupyter widgets that are available. So if you see any of these that you particularly like, you're probably in a good spot to use the render widget function. I don't know if these have all been tested with Shiny, but I think that this is something to explore a bit further. I'll link the list of these Jupyter or these Python widgets in the description. But also know that if you go into other, you'll see that this is actually also linked in the documentation. One other one what's worth mentioning is like IPyLeaflet. I think it's pretty cool to see. So we can see like a map like this is rendered via the render widget annotation. All right, what else? All right, we've done 2 of the changes. We got our heat map and we got our Altair chart here. I think the last thing we want to do is maybe do a sales by location heat map. And the IPyLeaflet is one way to approach this. I feel like for heat maps, one library that I have particularly liked is the Folium library. So I think it's worth discussing the Folium library a bit. So our code for this placeholder is right here, sales by location map. And how can we use the Folium library? Well, the first thing we need to do, and I might even just pull in something for this too, Folium heat map example. Okay, Folium.map, probably going to import it, pip install it, Folium map. You could do different types of tiles. I want a heat map. I don't need to see all these. Okay, so we ultimately need a data frame that has latitude, longitude, and a weight value. That's the 3 things that we need. That's basically what we want to replicate. Okay, so to import Folium like this. All these should be in the requirements.txt, so you should already have these. If you don't, just do a pip install of these different libraries. Okay, if we look at our data frame, we actually already have latitude and longitude there. So we basically just need the counts for those latitudes and longitudes to figure out our sales locations. So our counts in this situation would be the quantity ordered. And the heat map will be smart enough to find if you have similar latitudes and longitudes and similar quantity ordered by each other. Ultimately, your heat map will show those red zones. What we'll probably want to do is just go ahead and take we'll want to get our, how would we call this, def.plot US heat map. We would want to get our data frame, which is equal to the reactive calc. And then maybe we have a smaller data frame that's just basically like heat map data equals data frame, latitude, longitude, and quantity ordered. We might want to get the values off of that. Let's print the heat map data real quick. And a good exercise would be to try to get this heat map working on your own before you see the final code. Where is this data? I guess this is maybe not getting rendered yet. So I could do render widget. Now we see the data. That looks good. That looks like heat map data. So from Folium, if I go back to that, the first thing we wanted to do was build a map. So that might look something like this. This is a latitude, longitude start location. You kind of have to play around with this, I would say, to figure out what works best, but it's a good starting point. Then we need to add data to that map. Well, to do that, we can do heat map, and then we can pass in the heat map data, and we want to add that to our map, and then ultimately we want to return our map. And so let's see what happens when we run this. It looks like we have some sort of error, and it tells us that it's having trouble turning it into an IPy widget, and it instead recommends using Shiny's render.ui decorator. So let's go ahead and try that. Render.ui. And wow, we got the location map working, let's go. I think one thing that's interesting is Folium versus IPyLeaflet. This ultimately gives you an object that has like HTML source code all kind of built into it. If you printed map.representation HTML, you'd actually see all the HTML associated with this map get printed out. And I think as a result of that, like we can easily render this HTML. Render.ui is like the keyword, the annotation to use whenever you need to render HTML. And so something about this Folium library isn't friendly with IPython widgets, but it does have this HTML representation. So if you ever need to render HTML within your Shiny apps, render.ui is probably going to be what you need. And we see that we imported that over here, or I guess we're using it off of render. So that's cool to see. That's a nice chart for us. And let's see, I mean, that covers basically what we wanted to cover. We have everything here. It's really a matter of styling at this point, and that's what we're going to really focus on in the next video. But I think one final thing that's worth discussing is some different options we could use. Actually, there's a couple things I think are worth mentioning quick. So if you go to the documentation, I think there's some additional render annotations that are worth knowing. So one that we have actually already seen before is this render data frame. So we see it down at the bottom of our code, we're rendering this data frame. But I think one thing that is helpful to also know about rendering data frame is there's some additional customization options that we have available to us. One is there's these render data tables and render data grid. So I'll look at render data grid first. Basically, it gives us just a little bit more customizability of our data frame. So if I instead did render.DataGrid and then passed in the data frame or part of the data frame as we see we're doing here, and then ran that, we're not gonna see any immediate changes, but this now gives me some customization options. One that I like is filters. So if I turn that to true and then look at our app, we're gonna see now we have these different filters. So like if I only wanted MacBook Pros, I could type in MacBook Pro and we see we're only sorting by that. Maybe I only wanted addresses that include like San Francisco. So I could type in here. I could limit my quantity order to only like orders that were over 5 or something, or I guess maybe in our subsample we don't have any, but min 3 orders at a time. All sorts of nice filters you can do, especially when you have a bigger data frame. I only took the head of this data frame as a sample, but can be very helpful to have filters. You could also render this instead of as a data frame, but as a table, which looks a bit different, and you could have a similar render data table option to give you the same customizability. Now, if we look at the updated dashboard, I guess actually I think we passed this in normal. Render.table. We got a different looking table here. And you could have also done render.DataFrame and passed in render.DataTable. And you get something that looks like this. And you could also have passed in that same filters equals true. Get those options. You also could like make things editable here with the data table render. You could add a selection mode equals row, for example, and basically that then lets you highlight specific rows. It's all kind of personal preference, but if I run this again, now I can like click on these tables. So different options you have by using data table and data grid. Other things you might want to know about, go to the documentation. And there's like rendering text. So if you just want to render text on your screen, we might have seen this already. You can use the render.text decorator. You might want to render an image, let's say, in your dashboard. You can use the render.image. You could also render code. So if I find express.render.code somewhere here, I guess that the code is specifically, I remember seeing it in .core, render.code. If you needed to show code on your screen, you could use the render.code decorator. So like the render.code, for example, if I did with UI.card, and I did at render.code, passed in show code, and then I just like returned code equals print hello we see that rendered here, if it's helpful to do. So things like that. I use the 3 quote syntax if I needed to add a lot of code. I think one thing that might come here in the code range is syntax highlighting based on language, but not available currently. But you can play around with that. Cool. That's the basics. Really, really powerful to be able to render all these different types of charts in the same dashboard. Really encourage you to play around with this and see what you can build. All right, that's all we're going to cover in this video. If you enjoyed this video, make sure to throw it a thumbs up. Subscribe if you haven't already. In the final video in the series, we will see how we can style all of this and make it all look very nice and pretty. Again, all resources mentioned in this video are linked in the description. Check those out. Till next time, everyone. Peace.